Hi everyone, today I'm going to show you something interesting. I'm sorry if my voice is a bit hoarse, I got cold or something like that, and this is the reason I didn't publish any video last week. What you can see on the screen right now is a visualization I created using the Deneb custom visual and the Vega visualization grammar. I have already published Vega code for this visualization on GitHub. Deneb is really useful when we need some advanced features not available in Core Power BI visuals. For example, this yellow highlighting is not possible in Core Power BI visual. But sometimes we don't need any really advanced features, but we need something that looks much better than what we usually see in Power BI Core visuals. And today I'm going to show you a different implementation of the same visualization, fully created using only Core Power BI visual, a matrix visual. This is a matrix visual in Power BI. Not Deneb, not Zebra BI, just a native matrix visual. And how it's even possible to create a visualization like this using just a matrix visual? Well, since we have access to much larger images in matrix cells, we can create really advanced visualizations using SVG images. For this visualization, I used SVG images with height 35 pixels and with 250 pixels. We have 4 columns in this matrix. One column is for names. It's just a field from a table. And the other columns are measures that returns SVG code. Actually, you can see SVG code for the selection on the screen. Later, we can replace it with a custom tooltip. And on the build a visual pane, you can see the same that I already explained, that the name field is used for the rows of the matrix and 3 measures used for 3 additional columns of the matrix visual. Now let me show you what is inside of the measures. ACPY column of the visual contains black bars for this year or actual period and gray bars for previous year. Also, we have data labels for this year, and we have this black line for average of this year sales. And how we can create all these visual elements using SVG image. I have switched to tabular editor. Actually, I highly recommend this tool to use together with Power BI, but you can reproduce the same using native DAX editor in Power BI. This measure returns SVG code, as you can see here at the bottom of the measure. This is where I create SVG code. Everything else in this measure is to make some calculation to get some values required for the SVG code. Let me explain SVG code line by line. And I'm back to DAX editor in Power BI. It's the same measure, but before switching from tabular editor to Power BI, I just added a few missing comments here. Let me explain the SVG code line by line. So SVG code contains a few lines. First line is a header, which will remain the same for all SVG images. Let's keep this comment section with a rank variable for now. I will explain it later. And the main elements of this SVG image are line, 2 rectangles, and text labels, and SVG style. Line is for a vertical line that shows this year or AC average. First rectangle is for previous year gray bars. Second rectangle is for this year or actual period black bars. And the text line is for text labels for actual or this year data. Let me show you it on the chart. So we have a line for this vertical line, and we have rectangle for the gray bars, and we have rectangle for the black bars. And a measurer returns an image for a single cell in this column. So one SVG image is just a cell here. All other rows is the same measure but calculated in a different context for different salesperson names. So we will be looking what is inside of a single cell or single SVG image. You need to understand that the top left corner of the image is a position 0 pixels on axis X and Y and 0%. So you can use either pixels or percent to set a position of a visual element in the SVG image. And the right bottom corner is 100% or 250 pixels, because this is what I use it in format settings, the matrix visual. And also we have 35 pixels height of SVG image. Again, it's what is in format settings of the entire visual. And let me go back to the measure. Now more details. So x1 position of line is calculated in width average variable, and x2 position of the line is the same because it's a vertical line. Then y1 position is 0% and y2 position is 100% because it's a line that goes from top of the SVG image to the bottom of the SVG image. And we have stroke color for the line in color AC variable. And stroke width for the line is just 1 pixel. This is how we create the line. And what is behind the variables? Width average. Let me go to the width average variable. Width average variable is a division of average sales value. We divide it by maximal possible value for this year and previous year, because we need a scale for the axis X. We need to understand what the largest value we will have for this or previous year to display within 250 pixels we have for the image. So max value I calculated here. It's just the largest value from AC and PY, and I used this divide by 0.9 to make sure I will have enough space for the text labels in the cell. So the largest AC or PY bar will be a bit smaller than the entire image width to have enough space on the right for the data label. Let me go back to the SVG part of the measure. For the rectangle, PY gray rectangle start on 2% from the top of the image position, and black bars start on the 17% from the top position, and height of each bar is 67%. So we have, for the gray bar, we have 2% from the top of the image and 17% for the black bar, and each bar is 67% height of the entire cell or the entire SVG image. So we have these two rectangles, and then we have data labels or text tag in SVG. X position of the text is with AC or the end of the AC bar, but I use this DX to add 5 pixels between the end of the bar and the beginning of the data label. Y position is 55% or in the middle of the cell by height, and font weight is dynamically changed using a font weight variable because we need normal font weight for all the cells, but we need bold font for the total row or for the average values. And the text itself is value AC or this year actual period sales. And the SVG style part of the SVG code is another measure that contains just a style which is common for all SVG images in the visualization. It's a font family, font size, and alignment baseline for all data labels or for all text elements of the SVG images. Let me go back to the measure again, and I will show you the entire measure and explain what else we have here on this measure, starting from the beginning. So these two variables just contain colors for AC and PY bars. Value average is just a average sales for this or actual period. Value AC is where I calculate AC for the selected row or for the total row. If we has one value, person name. If it has one value, then it means that we are in the row for a person, and we need AC value there, and we need average value in the total row if has one value is false. The same for font weight. We need normal font, as I already told, for all rows, for all persons in the visual, and we need bold font for the total row. Value PY is just previous year value of the sales. And I already explained the max value, which is used for axis X scaling. And width average is where I calculate position of average line on axis X. It will be formatted to be in peasants of the SVG image width. Width AC is the position of the end of the AC black bars. Width PI is the width or position of the end of the PY bars. And now we have this run calculation. Why we need this run calculation? We need it because by default the column will be sorted by SVG code text. Let me go to the visualization. If you want to sort this matrix by this column, by default it will use SVG code to sort the column by SVG code. But as you know, when we sort in numbers as text, we get wrong results. For example, 1 and 10 will be nearby because this is how text data is being sorted. And we need something to fix this problem. So let me go back to the measure code. And I calculate a rank for each row, and I just add 100 of thousands to this rank to get something that looks like 100 of thousands and, for example, 1 for the first row in the matrix. and it will be similar but with 2 for the second row, and in this case sorting by these text values will be correct. And this is where we need this rank text comment in the beginning of the SVG image. So when a column is sorted by SVG code text, first row remains the same everywhere, and this rank will be different for every row, and everything else will be irrelevant because the rank row will be enough to sort our values. That's all what we have in the measure. It's really simple. It's much more simple than the Deneb and Vega. It's even much more simpler than the Deneb and Vega-Lite. Other measures are very similar, a little bit more complicated, but also very basic and similar to what I already explained. So now let me show you another measure for delta P by column. In this column, we display a difference between actual period or AC and previous year sales. So it's difference between what is displayed using black and gray bars here. Red bars are for the cases when previous year value was greater than this year value. So we have sales that decreased from previous year to this year, and we have increased sales when it's green on the right side of this part of the visualization. So it's just a little bit more complicated DAX measure. It's the same approach. We have this part that actually generates SVG image. We have everything before that makes some calculations for what we need in the SVG image. First row remains the same for every SVG. Rank is used for sorting. I already explained this part. Line here used not for displaying some values like average in the previous measure, but line here is used to create a vertical line for axis y. So it's in the middle of the image, so it's x1 and x2 positions always 50%, so it's just a line in the middle of the column or of the SVG image. It goes from 0% to 100% or through the entire height of the image. It uses gray color and line width is 1 pixel. Another element here is rectangle. We just need one rectangle for both green and red bars. We just calculate their position and width a bit differently. So in this case, you can see that we use x variable for x position and we use width variable for the bar width. And let me show you this x position of a bar. It's calculated differently. If value is above 0, then it's 50%. It means that green bars that display values that are above 0, they start in the middle of the image or on the or where we have axis y line that we already created. And if value is below 0, we create a red bar which will start on position that is calculated like 0.5 or 50% minus bar width in percent. And for bar width, we actually use this width variable, which is just our value, and we convert it into, we use the same scaling principle, and we convert it into percentage of image width. But in this case, we have this divide by 2 because we actually can have bars that take only half of the image width, because we need space for green bars on the right, and we need space for the red bars on the left. So I use this divide by 2 for the scaling. And another element is text, which is for the labels. Again, calculation are a bit more complicated here. Text answer is different for the below 0 and above 0 values, because we need align text to the left or to the right. Depends. Let me show you. We need align this text by the beginning of the red bar, and we need align this text by the end of the green bar. So we have this anchor, text anchor here for this purpose. Then we calculate X position differently for the green and red bars. The X position is -5 and 5, depends, is it on the left or right side. So I mean that we need to go 5 pixels to the left for this text, and we need to have 5 pixels to the right from the end of the bar for this text. This is for the X. Y position is again the same, in the middle of the image. I use it 55% because it just looks better than 50%. 50% looks a bit shifted, not right in the middle of the cell. And font weight again is different for the salesperson and for the total or average row. And for the number formatting, I use this string here because we need, for the variations, we need to add plus everywhere if the values are above 0. So it's clear that this is a variation. And for the next measure, everything is the same. Actually, we have the same green and red bars, just the height of the bars is different. But we have one more additional element for this black square. So let me show you the third measure. It's basically the same what we have in the second one, but we have height of the rectangle just 10% here for the red or green rectangle, and we have height 20% and width just 7 pixels for the pinhead, black pinhead. And everything else is the same. It's 3 very simple measures that creates really simple SVG code, and we have a visualization that otherwise is possible only using really complex Vega code in the Deneb visual. In the case of the matrix visual, as I already mentioned, it's not possible to add some advanced features like when I move in a cursor over a line, I can't highlight the entire light using yellow color like what I did in the Deneb, but everything else looks really good, and I think many of you didn't expect that something like this is possible using just a matrix visual in Power BI. So SVG images is a really powerful tool which can transform your native visualization into something that looks great and works really great, explains your data much better than just a table or matrix with default formatting. Thank you for watching my video. I hope it really changed your understanding of what is possible in Power BI using core visuals. So it's not always necessary to use Deneb, Vega or Vega-Lite. There are cases when Power BI core visuals are really powerful. You just need to know some tricks like how to use SVG images in a matrix visual. If you think this video was useful, please share it in your social media so more people can watch it and use it in their Power BI projects. In the description to the video on the bottom, you will find a link to get Power BI file with this visual, so you will be able to see the measures by yourself. You will be able to play with the visual. You will be able to adjust it, to copy some parts of it to your own Power BI project. Again, thank you for watching and subscribe to my channel to watch the following videos.